Welcome back to the Super Memory for Schools program. My name is L10. I'm in charge of 10th grade math. Today we will learn about the theme 1, Review of Linear and Quadratic Equations. Of the lesson, convert equations to linear or quadratic equations. First is about linear equations, which have the form ax plus b equals 0. For the case that a isn't 0, you will move b to the right-hand side of the equation and get negative b. Divide throughout negative b by a. Because a isn't 0, so we can do this division and you will get a root of x, which is negative b over a. It is the only root of this equation. So if a isn't 0, the equation has a unique root, x equals negative b over a. For case 2, if a is 0 and b isn't 0, a times x equals to 0. 0 times x is 0. Ax is 0, so b is 0. However, with the condition that b isn't 0, it is illogical, so this equation has no root. For case 3, if both a and b are 0, ax is 0 and b is 0. 0 plus 0 is 0, which is always true. So the equation is always true for every x in real numbers. Remember that this form of equation is a linear equation only if a isn't 0. If the equation has this form, you have to discourse all three cases, which are to have a unique root, to have no root, and to be always true for every x in R. Now we will apply the above cases to example 1. Solve and discourse the following equation for m. M times the difference of x and 2 equals 3x plus 1. Here I will do this for you. First, you may find it hard to realize that this kind of equation is the 1-degree one. However, as I taught you to solve the equation ax plus b previously, the first step is always converting to the form ax plus b. I will distribute m to x and 2 and move 3x plus 1 to the left-hand side. Then I will put the common factor x out of the parentheses, and the equation is the difference of m and 3 times x minus 2m minus 1 equals 0. So now we will discourse three cases. For the first case, a isn't 0, which means m minus 3 isn't 0. So m isn't 3, hence the equation has a unique root. X equals negative b over a. In this case, b is negative 2 minus 1, so negative b is 2m plus 1 over the difference of m and 3. This is the only root if m isn't 3. In the case that a is 0, so m is 3, if m is 3, we will calculate the value of b to see whether b is 0 or not before discussing the third case. For m is 3, we will replace m in negative 2 minus 1 by 3. So b is negative 7, not 0. A is 0 and b isn't 0, so the equation has no root. You can conclude, if m isn't 3, the equation has a unique root. If m is 3, the equation has no root. Those are steps to solve and discourse the equation ax plus b is 0. Move on to example 2. Find the values of m so that the following equation is always true for every x in R. In the previous question, which is solving and discoursing equations, you have to consider three cases. However, for this question, the condition is that the following equation is always true for every x in R. So we just need to consider the case that both a and b are 0. Before presenting the case, we need to convert the equation to the form ax plus b is 0. You can see that this equation is a linear one because x is 1 degree. Remember that x is unknown. M squared times x, you will move 4x to the left-hand side, so x is the common factor. The equation is the difference of m squared and 4 times x plus 6 minus 3m equals 0. M squared minus 4 is a. We have to convert the equation to this form to determine a and b before discoursing. To meet the condition that the equation is always true for every x in R, both a and b must be 0. So a is m minus 4 equals 0, and b is 6 minus 3m equals 0. The root of the above equation are m equals 2 or m equals negative 2. The root of the below equation is m equals 2, so the common root is m equals 2. When m equals 2, so the root of both equations is 0. Therefore, when m equals 2, the equation is always true for every x in R. M equals 2 is the answer to the question. Look at this case that m equals negative 2. When m equals negative 2, the root of the above equation is 0. But the root of the below equation isn't 0. In other words, when m equals negative 2, a is 0 and b isn't 0. So when m equals negative 2, the equation has no root. I just want to explain more about that case. The answer to this question is still m equals 2. Find the values of m so that the following equation has a unique root: 2mx minus 1 equals x plus m. To solve this equation, we do 2 steps. Step 1, convert the equation to the form ax plus b is 0. Step 2, consider the case a isn't 0. We've learned that with the form ax plus b equals 0, when a isn't 0, the equation has a unique root. This equation is easier than the 2 previous ones. First, convert the equation to the form ax plus b is 0. Then, to meet the question's condition, a isn't 0 or m isn't 1/2, that is the answer to this question. For such questions, you just need to remember 3 cases and discourse them. The replacement step is very simple. You can look at its form again. A isn't 0, so the equation has a unique root of x, which is negative b over a. A is 0 and b isn't 0, so the equation has no root. A is 0 and b is 0, so the equation is always true for every x in R. One more thing to remember is that an equation is a linear one only if a isn't 0. Thanks again for your listening. See you again in the next part of this theme.